everyone. Today we'll see another most important, interesting and another annoying thing in electrical engineering, that is inductance. We know inductor will not allow sudden change in currents. So now we'll see why and how inductor will not allow sudden change in currents. Okay, let's see that. So I have taken a simple circuit where we have an inductance or inductor which is fed by voltage source V, some DC voltage, and through a switch. So at t is equal to 0, at some instant I close the switch. So before this closing the switch, what was the current here? As it is an open circuit, there is no current flowing. But the moment I close the switch, this voltage source has a closed path now. So there will be an attempt of current to flow because we have a closed path and we have a voltage source. So there must be a current flowing. But we say inductor will not allow sudden change in currents. So why inductor will not allow? Because we have a voltage source and there is a closed path, there must be a current according to our simple basics KVL and KCL, right? So now how the inductor is not allowing? Who is the inductor to not allow? Let's see. We know VL, voltage across inductor, is equal to LdA by dt. So if there is a change in current, previously current was 0, the moment I close the switch, there is some attempt of current to flow. So there is some change in current within how much time? Within 0 time. Because the change is happening within very small time, almost 0 time. So what will be the value of this LdA by dt? We have, there is an attempt of current to flow within small time. So this VL will be, if this dt is 0, this VL can be infinity. It can be infinity. It is not infinity, it can be infinity. And the direction of this VL will oppose the cause of creating it according to Lenz's law. So what is the cause of creating it? This current. So this VL will oppose this current. So this is a VL. VL will be in this direction. Now, as there is a induced EMF in inductance, there is opposition for this voltage. So current will be 0 at the moment of t is equal to 0 plus. So slowly this VL will reduce and this current will increase. Okay. Now you may get a doubt, till what value it will go? Will it go to infinity or will it go to some value? It all depends on this dI by dt. Okay. Now, so as switch is closed and current is flowing, after some time, maybe 100 seconds, maybe 100 minutes, it doesn't matter. After some time, after some big time, I open the switch. Be careful here. After some big time, I open the switch. So before I open the switch, let's take current flowing through the circuit is X amperes. Before I open the switch, that is at t is equal to 100 minus, current flowing through this circuit is X amperes. Now the moment I open the switch, that is at t is equal to 100 plus, what will be the current in the circuit? So according to the definition of inductor, it will not allow sudden change in currents, which means current must be still X amperes. Right? Now the question is, what is this? I open the switch. Switch is open. There is no path for the current to flow. As there is no path, there must not be any current. But we say inductor will not allow sudden change in current, so it must be X amperes. So how it is happening? Are you getting the point? The point is, at t is equal to 0 minus, we have X amperes. At t is equal to 100 plus, we open the switch. So there must be 0 current because it's an open circuit. So how it will maintain still X amperes? Let's see that. As I said, the moment I open the switch, current will try to become 0 from x, it will try to become 0 from x amperes. Within how much time? Within 0 time. Within 0 time. So what is the value of VL? Again, it can be infinity. If the dt is 0, it can be infinity. Okay. So infinity means it will oppose again. It will oppose the direction of VL. Will oppose the cause of creating it. Who has created the cause? Current is becoming 0. That is a creation. So it will not allow current to be 0. At any cost, it will not allow current to be 0. Then what it will do? If it is open circuit, then what it will do is, it will induce a voltage in the same direction. It has to drive the current in the same direction. It will induce a voltage in such a way that the current will be in the same direction, same x amperes, same direction. But as you said, this is open circuit. But here, though it is open circuit, what I said, this voltage can be infinity. It can be infinity. So it can deliver very high voltage, which will appear across these two contacts. That high voltage will appear across these two contacts, which will lead to give a spark, which will ionize the air between these two contacts, and there will be a spark. Through spark, current will go. That's the beauty, sir. So it has ionized the air in between the contacts, and it allowed the current to flow. Those which is open. Did you see this? That's what the inductor. And this is the reason why when you try to switch off a motor or any inductive load for that matters, you will observe a spark for sure. And this is the reason why if there is a gas leakage at home, they will say not to change the switch positions. Don't turn on as well as don't turn off. So if you do this, if you have an inductive load, that will give a spark, that will light up, that will give a blast at your home because of the gas leakage. So you will celebrate Diwali at home. Of course, there won't be any celebration if it's a gas blast, is it? Okay. So that's the point, sir. I know it is difficult to understand if I give this theoretical explanation. So that's why we decided to do some experiment. So I will show you an experiment. So there I'll explain how it is actually happening through experiment. And I recommend not to try this experiment what we are doing at home, because that's very dangerous, because it can give very high amount of voltage. Okay. To understand the inductor much better, let's see a practical and a daily use application, that is a fluorescent lamp. If you understand this operation, the operation of this fluorescent lamp, how it works, we can understand inductor very clearly. So let's get to it. We know this is a fluorescent lamp, this is choke, this is a bulb or lamp, this is the starter. Okay. So these are the three elements. We have a power supply here. Now let me connect starter to this. I am connecting the starter. So we now switching on the supply. You observe, yeah. So what did you observe here? In this process, what did you observe? Just I'm playing the same clip over here in a slow motion. You notice it. You notice two parts. One is, notice in the recap what I'm playing here, the replay. You notice the moment I switch on this, what has happened here and what has happened to the light. You observe these two, this lighting and this lighting. Okay. Did you observe? That's fine. Keep it noted. I'll explain that point later. Now, let me remove the starter. I remove the starter. Starter is not there in the circuit now. So the bulb is still glowing. Is it clear? Okay, let me power off the supply. Power is off. So what did you understand here? Starter is only for starting the bulb. Once the bulb is started, I don't have to have this in the circuit. We can remove it. Even though I remove that, still light is glowing. That's why it is called as starter. This is number one. Now can I light up the bulb without the starter? Let me not use the starter now. Can I glow the bulb? See that. I am switching on the supply. There is no starter. Starter is not connected. So is it bulb glowing? No, power is on, but bulb is not glowing. Can we light up this bulb without the starter? Let's try. Yeah. Do you see? We could light up this bulb without using the starter by just shorting these two terminals. Now observe another thing. Light is glowing. Now what if I short this once again? Light has stopped. Light has glowed. So you record these things, keep these things in your mind. I'll explain why and how it is happening. So now let's analyze the experiment what just we performed. So again I am saying that is one of the dangerous experiments which I performed so far. That's very dangerous. And when I was performing the experiment, I was in a safe conditions. My team has made me so safe and secure. And luckily that has saved me and make me alive right now. Otherwise I would have died. Because when I was doing experiment, I mishandled the inductor. So, I couldn't imagine that situation right now. I mishandled it, but still, because I'm in a safe environment, I could be alive. Otherwise, I would have gone. Okay? So be careful. So let's analyze it. Now let us look at the schematic of the experiment what we have seen. So this is a main switch and choke, fluorescent lamp, starter, and see here, this is a filament, and this is also a filament. Both ends we have one filament each. So now one point you should observe, there is no electrical contact between these two. There is no electrical contact between these two. It is filled with gas, some inert gas, and some mercury, and inert gas like argon, neon, some gases are there, but there is no electrical connection. But still, when the bulb glows, current flows through this path. So the point is, though there is no electrical connection, how current is flowing? That's number one. Number two, what is the length of this tube? Around 1 meter? Around 1 meter means around 100 centimeters. Now tell me, to ionize the air of 1 centimeter, how much voltage do we require? We require 30 kilovolt is required, peak value I am talking about, to ionize air of 1 centimeter. So if this is a requirement for 100 centimeters, how much do you require? 30 kV into 100, that is 3000 kilovolt. So to ionize this gap, you require 3000 kilovolt. And of course, if it is filled with air, you require this much. But it is filled with some gas, you won't be requiring this much to ionize it, but you require little more than 220 definitely. For just 220 volts, this gap won't be ionized. You require a voltage in terms of thousands of volts. You require thousands of volts, around 2000, 3000, some thousands of volts to ionize this gap. But what is the voltage we are having? We have 230 into root 2 peak value. 230 root 2 is the voltage maximum what we can get here. So let's analyze that experiment. With these points, let's analyze the experiment. We are now closing the switch. Switch is closed. So as switch is closed, current flows through this path. I think you could see this current flow. Now as current is flowing through this filament, this will heat up. That's what you see both the ends in old fluorescent lamps. You will see red color. They will glow red color at starting because they are getting heated up. As current is flowing through this, they are getting heated up, and they will release some electrons into this chamber, into this lamp. They will release some free electrons, and these free electrons will hit the gas particles what is inside, and they will release again further free electrons more. Now the moment we open the starter, did you see what has happened? The moment this starter is opened, we know this inductor will not allow sudden change in currents. So as we opened it, there will be high voltage will appear across this as well as these two contacts. There will be a high voltage appearing across these two contacts as well as these two contacts. So that's why there was a flash, because this high voltage has ionized the gap. So there was a spark, but this ionization is not consistent, so that's why it has gone dark. Now once again, let's close the starter. We close this. So again current is flowing. Now we'll open it again. The moment we open it, again there was a flash, but the ionization is not good enough. That's why lamp has go down. Now let's try again. We'll close. Again we'll open. There is a flash. We'll close. Again we'll open. So when we're doing like this, closing and opening, at one instant light will glow. At one instant light has glowed. Now the current is flowing through this, not through this. Are you clear? Now as current is flowing through this gap has ionized, it is giving light to us. Okay. Now this is the purpose of the combination of starter and choke, and this is how you are getting high voltage which is required to ionize such a long gap by this choke with the help of starter. So now the common doubt is, once it has started, should I remove this choke as well? Because once the high voltage has come, once it has lighted up, do we require this choke as well? Let's check that. We know this gap has now ionized, and the resistance of this gap is some R value which is very less, because we have a good number of electrons and it got ionized. Resistance is very less. I'm applying here 230 volt RMS, and resistance is very less, maybe let's take 2 ohms. Okay. Now what will be the current through this bulb? Current through this bulb is 115 ampere. As more current is going, the resistance will keep reducing because more number of electrons are there. So the resistance will keep on decreasing. As resistance keep on decreasing, current will keep on increasing. So there will be a blast. It will damage immediately. Because current is continuously increasing, we'll have to limit the current. Now the moment is, the choke is still there. As in the circuit, choke is still there. The opposition offered is not just R, it is R square plus XL square under root. Now this XL will now limit the current within the range. I hope we are clear. Okay. So now while the light is glowing, what if I close the starter again? As I close the starter, now current is flowing through this, not through this bulb. Okay. So as current is flowing through this, there is no light here, and this is what the inductor is all about. And this is how we say inductor will not allow sudden change in currents. And again, this is the reason why all of you are doing this fluorescent lamp experiment in the first year. Are you doing the experiment in the first year? Yes, we are doing. Why are we doing? To understand the complex part of electrical engineering, that is inductance. To understand that clearly, we are doing that experiment. But what we do normally in the lab, we just go to the lab, we'll connect it, we'll switch on, we'll switch off, and we'll come back. We don't observe all these things. I hope we are clear with inductance. So in the next class, we'll see with another concept. Till then, keep watching us and share this video with your friends. And if you have any doubts on the topic what we discussed, you may discuss with us through interactive live session what we're having. Almost monthly twice we'll be having a live interactive session through Facebook Live. You may check our Facebook page for our live session details, what time, what date it happens. Thank you for watching. Keep sharing.